All right, let's take a look at lesson 10.5 here, the binomial theorem. First review question I have is, what is the sum of this infinite geometric series? All right, so what are some key words you see in the question? Mark, I'll let you take some, and now you're out. What are other key words that other students see? Infinite and geometric. Okay, I'm going to start with geometric. On our formula chart, we have a formula for geometric. All right, you got to highlight it. Under sequences and series, I'm going to go to the nth term of a geometric sequence, and I'm going to take that formula. That's going to be the formula we're going to use. AN equals A1 times R to the power of n minus 1. What do I do with the sum? Or what symbol will calculate a sum?
Sigma.
Sigma. What does sigma represent in the formula, or what does it replace, I should say? AN equals. This part is going to come out and be replaced by sigma. Now, for my sigma, I want to put a parentheses around all that. Whenever we write a sum by hand, we should have an n equals 1 as a lower bound. The upper bound depends on the problem. On this, how many values do we have written here? Or how many terms? I see 4 terms, but I see a dot, dot, dot. This says infinite. Now, can we put infinity in the calculator? No. So we have to replace it with some number. What should we say to replace the n with? About 1,000. That's great. That's a large number. It'll represent infinity. And our problem, what is our A1? Negative 5 over 4. Great. Negative 5 over 4. Negative 5 over 4. The only thing we now need to find is the ratio, because remember, with sigma, never replace that n. That's where the calculator will substitute in the sigma values into that n. So never replace this n. Never replace n inside of sigma. So we're going to leave that in there. But I do have to find the ratio. What's our formula to find the ratio? Divide. Divide what? A2 divided by A1. That would do it. A2 divided by A1, which in this case, you'd be dividing 1/2 divided by negative 5/4, which if you know the decimals, it'll be easier to use decimals here in the calculator to make sure I don't make a mistake. What is 1/2 as a decimal? 0.5. And you might not know this one, but if you think in quarters, like there's 4 quarters to $1, 1.25, it's negative, so negative 1.25. I'm going to type it in like that to the calculator, make sure I don't make a mistake. So I'll go over to Desmos. I'm just going to use a blank one here. And so you could do division, then 1/2 divided by negative 5 over 4. But if you're afraid you might mess that up, just use the decimals. So 0.5 divided by negative 1.25, and you'll see the number is the same. We could do the decimal, or we could use the fraction. What do y'all want to use, decimal or fraction? Decimal. Okay, so we will say that is negative 0.4. Right there. I'll let you get your solution. Pause the video, and you can type this down yourself to figure out what is the sum. Now let's take a look at number 2. A ball is dropped from a height of 5 feet, and the return bounce is 60% of the previous height. How far does the ball travel when it hits the ground for the 5th time? Round your answer to the nearest 1/10 of a foot. So we saw this at the end of lesson 10.3. I'm going to do a quick sketch, and you can walk me through the change we made to make the problem easy to use the calculator. So the ball falls and it hits 5 times. So each time it bounces back up, that's 4 bounces, 5 bounces. Okay, so the ball bounces 5 times. It originally falls 5 feet, and each subsequent bounce is 60% of the previous height. So you could go through and say, all right, what is 5 times 60%, which is like 60 over 100 or 0.6, which that would be 3 feet. But if you went through this way, it'd take you a long time, and you might mess up, because what's the thing that we might mess up? You have to count it twice. Why twice? This ball will go up 3 feet and also down 3 feet, whereas with a 5, it only went down. And so it's an easy way to mess up. So what was the adjustment we made for the calculator's sake to use sigma? Okay, they go to the first parabola and make it kind of like a full, I said first parabola, make it where the ball falls, change it to where it looks like a parabola. Now we have 5 identical type of bounces. What's our top value going to be? Is it going to still be 5? No, now it's going to go up 5 and down 5. So what's that number going to be? We're going to say that first term is 10 feet. The ratio, what's our ratio as a decimal? 60% is, if you divide your percentage symbols out of there by dividing by 100%, you get 0.6. And we're going to have 5 bounces, 1, 2, 3, 4, and 5. So this type of problem, is it arithmetic or geometric? I should have asked that question. Geometric, because each time you're multiplying by 0.6. So we go to the formula chart. I already have it highlighted. There's your formula. Since I'm finding a sum, I need to change that formula. What changes when you find a sum? Okay, I want to make sure it's more than just mark. When you're finding a sum, what do you take? What do you replace? A and equals, and it doesn't matter if that's arithmetic or geometric. It always works that way. If you're doing a sum, that part gets replaced. N equals 1. How many bounces are we finding? 5. So that'll be 5 as the upper bound. What is A1? I'm going to put parentheses around the rest of this, right there to there. What is our A1? We decided that's going to be 10 feet. That was 10. What was our ratio? 0.6. And that'll be raised to the power of n minus 1. Do I need to put a 5 for this n? No, that's where the calculator will plug in the sigmas. So I'll pause the video here and let you, actually, no, if I pause it here, we would actually not get the correct answer. Because what do we, on our diagram, we added a part that's not originally part of it. How much distance do we add? 5. We added 5 over here that's not originally part of the problem. So to correct for that, we need to subtract 5 on the end. That should give you the correct answer right there. Now I'll pause the video and I'll let you do it on your own. All right, new stuff here. We're going to tackle the binomial theorem. Now, I like binomial theorem. I'm going to get to your first slide that you have on yours. What binomial theorem does is it's basically, this guy named Pascal is credited with a lot of this. What he what he did is he came up with basically odds for gambling. That's how this is applied in the real world most often. Gambling, yes, you heard it here, gambling. And so here's the idea. He's got all these numbers on this triangle, and what it represents is a binomial. So bi, like a bicycle, implies what? 2. So he takes a binomial. We'll just call it a plus b, and he raises it to some power. And what his triangle does is it represents, if you expanded it, depending on the power, what the coefficients would be. So, for example, if you had a power of 0, a plus b, and he raised this to the power of 0, what you would end up with is anything to the power of 0 ends in, or produces the value of 1. You would just have a 1. You see how that's a 1 right there? Okay, going on from there, this will now represent the variables as well. If you had a plus b to the first power, right here, and you had anything raised to the first power, guess what it's going to be? Itself. So it'd just be a plus b. Now notice, how many a's do you have? 1. And how many b's do you have? 1. No, that's why you have 1 and 1. Now, the next one we could write out, I'm not going to do it. I'm just going to write it how I have been. A plus b squared. If you multiply this out, a plus b times a plus b, and you FOILed it, you would come up with 1 a squared plus 2 ab's plus 1 b squared. Are you seeing how the numbers are corresponding to the Pascal's triangle? You seeing how these are matching up? Okay, and so to do the next one a little bit quicker, well, I'll say a little bit quicker, as fast as I can. A plus b cubed. If you wrote out a plus b times a plus b times a plus b, and you FOILed all of that out, what this is saying is you would have 1a cubed plus 3a squared b to the first plus 3a to the first b squared plus 1b cubed. I'll write it one time here, and I'm going to be done after this. You would have 1a cubes plus 3a squared b to the first. Do you see what's happening to my powers? I hear they're going up. That's not exactly true. What's happening to my powers as I go? They're not all increasing. So what's happening to my a power? It was a 3. It's now a 2, a 1. And it's not even there, like power 0. What's happening to the b's? Not there, like power 0, power 1, power 2, power 3. So a's are decreasing while b's are increasing. Are you noticing this? These happen to be their coefficients. So you might be saying, how is this dealing with gambling? Well, in gambling, there's only 2 situations. When you go to gamble, you can either win or you lose. And how this is applied to gambling is we're going to say this, the A will, at the end of the lesson, it's going to represent winning, odds of winning. So the first term today, you're going to hear me talk about winning. The back term, the B, you're going to hear me talk about losing. And N happens to be the number of times you play the game. Number of plays. Number of plays. So let me walk through how could you use Pascal's triangle. Let's say you wanted to take a snapshot of people playing some game 6 times. 6 different people are going to go play the roulette wheel. Or not 6 different people, excuse me. A person's going to play the roulette wheel. Do you know what that is? Yeah. Okay, 6 different times. What this would mean is that for every one person who plays that 6 times and wins all 6, there will be 6 people who would win 5, lose 1. There would be 15 people who would win 4 and lose 2. There would be 20 people who would win 3 and lose 3. Do you see what I'm doing there? My winning is counting down. My losing is counting up. There would be 15 people who would win twice, lose 4 times. 6 people who would win once, lose 5 times. And there would be 1 sorry person who lost all 6 times. Do you kind of understand what I'm saying there? So 2 people, or you're going to play the game 2 times. This is really easy. You're going to play the game 2 times. The odds will be that you win how many times? Win once and lose the other. So if you're going to play 1 time, for every 1 person who wins their 1 play, there will be 1 person who loses their 1 play. That's how the numbers work. Okay, so with that in mind, we're going to work on these expansions, and we're going to start mathematical, and we're going to end real world gambling. I'm going to talk as if it's gambling the whole time. So the A represents what? What did I say A represents? Winning. What's the B represent? Losing. And the 6 represent? And I'm going to use a number sign, number of plays. Okay, so if you were going to expand this without actually multiplying A plus B times A plus B times A plus B times A plus B 6 times, the way you do it is you would go to your Pascal's triangle and get the row 6 values. Whoops. So look on row 6. Here's row 6. It's the one that starts 1 and 6. This is row 6. Here are my values. Let's write those down. Okay, I can't have them on both. Actually, I could. Copy. Okay, let's paste those there. All right, what are the row 6 values? They are 1, 6, 15, 20, 15, 6, and 1. So here's what that means. A plus B to the 6th power. If you multiplied all that out, you would have 1 A to the 6th power. You would have 1 A to the 6th power. Technically, it's B to the 0. You don't need to write that part, nor do you need to write the 1. So for that reason, I'm going to now erase it. You would have one of those because it starts with a 1. Plus, you would have 6 A to the how many powers? 5. B to how many powers? 1. Because they have to add up to the B that's 6. Do I need to leave that 1 right there? No. So just write it as B. That means B to the 1st. Plus, what comes after 6? 15. Which means you have one person who wins every time. You have 6 people who wins 5, lose once. You'd have 15 people who would win how many times? 4 games, and they would lose how many games? Twice. You're getting the pattern, maybe. Maybe. What comes after 15? 20. You'd have 20 people who would win 3, lose 3. You would have 15 who would win 2 and lose 4. 6 who win once. Do I need to actually write A to the 1st? I could just write A, but they would lose 5 times. And then finally, one person who would lose all 6 times. And so you only have to write B to the 6th, like that. That right there is your answer. That's your answer. Now that is quite an expansion. What I'm going to do today, though, as we go, is I'm going to have a shortcut, and I'm going to say, hey, we're going to find a certain term. And so we're going to focus on certain terms as we go, and I want to point something out. This right here is called your first term. First term. This would be called, why did I write first term? Let me just say A1, first term. What would you call the second term? Actually, I will do that so you're not confused with this A. This is a totally different A. So I'll just go back. That's the first term. Sorry, changed my mind what I was doing halfway through. That's the second term. What would you call this one? Third term. Okay, I want you to notice something. If you're told to find the third term, does that mean you use a power of 3 on the A? Does that mean A will have a power of 3? Look up here. Does it? Does it mean your B will have a power of 3? No, actually, it'll never be the same number, ever. If you're trying to find the third term, it'll never be that number. Here's how you can do it, though. You can say the n minus term number plus 1 will always be the value. Now, that's going to be a huge shortcut today. To find the power of the A term, that's how you'll do it. The power of the A term, power of A term. Power of A, sorry, let me just say power of A equals n minus term number plus 1. Now, why do I say that? Because what I'm going to do today is I'm not going to say find this whole expansion. I'm just going to say find the third term. And what you would do for the third term is you say, okay, what's 6 minus 3? 6 minus 3? 3 plus 1? 4. You'll have A to the 4th B squared, and you would go and get off here and get the third one. 1, 2, 3. See how it's a 15? And you'd have 15 A to the 4th, because that was 6 minus 3 plus 1. That's what we're going to do today, just to shorten it up for you. Now, you might be confused. It'll start to make sense as you see this a few more times. All right, part B. Let me copy this. Part B here. It says use Pascal's to expand this. So now I'm moving a little bit away from A's and B's, and I now have a 3x plus 2. This is still going to refer to our winning. We're going to think of this as winning. This is going to be referred to as losing. What's the 5 represent? The number of plays. Number of plays. You have it. Okay, so let's work through this. If I was going to try to expand this, you would first go to row 5. So here's row 5. My numbers are 1, 5, 10, 10, 5, 1. Now here's what that means. When you expand that out, 3x plus 2 to the 5th power will be equal to 1 times 3x. It's like saying one person who wins all 5 times. 3x to the 5th power. There would be, for every one individual that wins every time, there would be 5 individuals who win 4 of the times, but lose once, which 2 represents losing. So they lose 1 time. 2 to the first. Again, I wouldn't have to write that first there. So I'll erase it. You don't actually have to have 2 to the first. Maybe I'll leave it there just so you can see how they count. Okay, for every one person who wins every game, 5 people win 4 of them, lose once. 10 people, well, what did the 10 people do? Win 3. So 3x to the 3rd, lose how many? 2 times, because we're playing 5 here. Now, not only are there 10 people who win 3, lose 2, there's also 10 people who win 2, lose 3. There will be 10 people who win 2, lose 3. There will be 5 people who win how many times? Once. And lose how many times? 4 times. Finally, there will be 1 person who loses all 5 times, does not win at all. Now this one can be simplified. We can use the calculator. What I will not type in the calculator are the variable x. So each time I'm going to type these in without the variable x. So when I first type in, not that I have to put the 1, you don't have to write 1s in there, but it'd be 1 times 3 to the power of 5. It's 243. So that right there is 243x to the 5th power. So I didn't type in the x because the calculator won't do anything for that. So it's 243x to the 5th power. So this value would be 3x plus 2 to the 5th will equal 243x to the 5th plus, now I'll type in the next one, 5 times 3 wins, or not 3 wins, I'm sorry, 4 wins. What? 4 wins and 1 loss. Again, I don't have to do the first power, but I'll do it here just so you can see it. 1 loss, 4 wins, and right now we just had the odds at 3 and 2. We'll get to that in a little while. The number is 810, so our coefficient would be 810. 810 x to the 4th power, because that's the part I could not type in the calculator. Got to add that in. Then I would type this in the calculator. Again, I can't type in the variable x, so it'll be a 10 as my Pascal's coefficient. I have 3 winners, 2 losers. That needs to be a power. Power 2. There you go. 3 winners, 2 losers. 1080 is my number. So it'd be 1080 x cubed. I will also have, let's see here, 10 of 2 winners and 3 losers. So I'm getting 720 there. 720x squared. We'll have 5 that win 1, lose 4 times. 240. Again, the one thing I couldn't type in the calculator is x to the 1st. It's just x right there to the 1st power. And finally, 1 times 2 to the 5th. So I don't have any wins, but I have 5 losses and a 1 out in front. That's 32. And that would be my expansion. Now that's a really long way to get an answer. Would y'all agree with that? It takes a while. All right, you're already grumbling at me. Here's what we're gonna do starting now, is I'm gonna tell you to find a particular term. I'm gonna say find, like, for example, the x squared term. And so here's how I'm gonna suggest you do it. And to find the x squared term, what you will do is you will start off with the highest amount of wins is x to the 5th power. Would y'all agree with that? The most you could win is 5 times. What's the second most wins? The second best situation is to win 4 times. What's the next best situation? 3 times. What's the next best? 2. Okay. I came to the squared term. You see how I come to that now? If you're looking for the squared term, you would then match out which Pascal's number would that be? 1, 5, 10, 10, 5, or 1. 1, 5, 10. This is a 10. You see how this is 1, 5, 10. You follow what I'm doing? All right. From here, now you know the Pascal's number would be a 10. If it's x squared, that means you win 3x twice, and you would have to lose 3 times to add up to 5. That's what the numbers you would type in the calculator. So from here on out, I'm going to tell you to find a term. You'll need to find Pascal's by writing them out, like I just did, to find out what's the corresponding Pascal's number, which in this case, it would have been 10. And then you'd say, okay, if it's 10, it'll be 10 times. You'll take your winning value, 3. We want to win twice. The losing value is a 2. If you win twice and play a total of 5 games, you would have to play 3 times, and you would type that in the calculator to get your answer. From here on out, that's how I'm going to walk those through to you, okay? So first DOL, I want you to find the x squared term of this problem. You could try, if you wanted to do the whole thing on your own. I want you to find the x squared term. I want you to look at the x squared term to find out which answer is correct. I want you to determine which x squared term is the correct value here. You can use Pascal's triangle. There's your number to go on Pascal's triangle to solve. Let me paste this here for you. All right, I'm going to pause the video and let you work. All right, one thing I forgot to go full circle on. At the start, I gave you a little formula and I said, hey, I'll come back to this to make sense out of it. And I never did. If you're looking for the x squared term, the way to think about this is, remember how I said you take your n minus the term value you're looking for, which on this one is x squared, like a power of 2. So n minus, I'm going to say the power here, plus 1. This will also find the term, the Pascal term number. Pascal term number. What am I meaning by this? Okay, on this problem, what's our power? 6. What power are we looking for? 2. What is 6? 6 minus 2 plus 1. 5. So what you should be doing is you're looking on Pascal's on row 6 at the 5th one. 1, 2, 3, 4, 5. What number should you be using? 15. You're using 15. Does that make sense? Also, what would work if you just do your algebra, the way I wrote it the first time is I said the power, but I put the power on the other side of the equal sign and the Pascal term over there. You could switch those around. If you do algebra, you just add power to both sides, subtract this, and you can see how that could replace one another, and it would work that way as well. So I'm going to pause this again. All right, so now example 2, it says use Pascal's triangle to expand this. Well, I'm going to change the instructions here for the sake of time. What I'm going to do is we're just going to find a term, one term at a time. And so let's just say use Pascal's triangle to find the third term. So of this problem. So first, what row would you be looking on Pascal's? That's the row. You go to row 4. So you go to row 4. Here's our values. And if you were looking for the third term, you could just count across to find your Pascal's number. So this is the first, second, third. You see how I'm landing on a 6? You see how I have a 6 there? Yes, no? Okay, that's going to be the third term. So here's how I would use Pascal's to find the third term. The third term would equal 6 times. All right, in this problem, what represents winning is 1x. I'm going to put a 1 this time because in the calculator, I will not put the x, but I'll need a 1. And so I want to put 1x there. And then losing goes next. What's going to represent losing? Minus 2y. And the calculator will just be minus 2. Now, on the third term, this is where the formula comes in handy. This value is 6 minus the third plus 1. What is 6? Not 6. Why did I say 6? We have row 4 here. It would be 4 minus the third row plus 1. What's 4 minus 3? 1 plus 1 more? 2. That's what number goes there. Now, whatever this power is, winning plus losing has to add up to 4 plays. So if you won twice, how many times did you lose? Okay, that's one way of doing it. Here's another way of doing this. From over here, the perfect situation in gambling is to win every time, lose every time, to split. What's perfect? What's the best? To win. Winning all 4 is here. This is like winning all 4. Winning 3, that's like winning 2. You hear me say winning 2? So winning 2 means you have a power of 2 right here. Do you follow how I explain that? This is like winning 4 times, winning 3 times, winning twice, winning once, not winning at all. That's like the odds. Since we're winning 2, I put that on the number of wins. This will be the number of losses. So let's go type this in the calculator without the x and y. So it's going to be 6 parentheses 1 raised to the power of 2. And I know if you have a 1, you don't technically have to write any of those ones. And then it was a negative 2 raised to the power of 2. So the third term would be positive 24. The third term would be positive 24 x squared, because now I know I couldn't put it in the calculator, but it does have an x squared, and y squared. That would be the third term. You follow me? Now, before I tell you to find one more, I'm going to just find another random one. What do y'all want to find? It looks like there's 5 total terms. Y'all want to find term 1, 2, 4, or 5? We already found 3. I hear 4. Let's find term 4. So what if we wanted to find the 4th term? Find the 3rd and 4th. I'm going to change the instructions. Find the 3rd and 4th terms. Okay, so the 4th term. Here's what you would do. Go into Pascal's. You would count across and you would say, all right, 4th term means not 1, not 4, not 6, not, wait, which one would I choose? The 4th. So it'd be this 4. This coincidence has it, it's a 4. So Pascal's number is a 4. I'm winning 1x times. Odds of winning is 1x is technically what that would be in a real world application. Odds of losing is a negative 2y in a real world application. That's the odds of winning, odds of losing. Now, if you're on the 4th term, how many wins is that? Remember, a perfect situation is winning all of them. Here's winning all 4, winning 3, winning 2. This would be like winning once. So if you win 1, if you win once, how many times do you lose? You would win, or you would lose 3 times. So let's type that in the calculator. And so it would be 4 parentheses 1 raised to the 1st. Again, you don't have to type it in if it's a 1. You could skip those, but for the sake of this problem, I'll do it to the 3rd power. It would be a negative 32. Negative 32 is my coefficient. So negative 32, and then I would add in the variables. Negative 32, x to the 1st power, y cubed. Now, one more way I could have done that finding this number here is you could have said for the powers, since the power is 4, 4 minus 4 plus 1. What's 4 minus 4? 0 plus 1. That's why that's a 1 there. You could have done it that way as well. So that's kind of a shortcut of how to find the terms. All right, this time I want you to find the second term. I want you to find the second term. Find the second term, which basically, to make this simpler, is from the answer choices. I want you to determine which of these values, I'm underlining all the second terms, which one is correct given this problem. Let me get you a little. There you go. I'll let you look and find the row, find your value. You can go from there. Pause the video if you need time. So now let's take a quick glance at the formula chart. When you check out the formula chart, do you see the Pascal's triangle anywhere on the formula chart? No. So there could be a problem of like, hey, if this is something that's tested, how will I get my Pascal's triangle? Well, one is you could come up with this on yourself. I don't know if you've realized the pattern, but what happens is to get any value, you just add the 2 above it. So you start with 1 and 1 1 below it. After that, like this 2 is generated because 2 1s are up above it, and so on and so forth. This 21 right here, it's because it's underneath the 6 and 15. Now you could come up with your own, but there's a quicker way. There's a way in the calculator. So how does it work in the calculator? It's this thing called NCR. And so that's what I'm going to show you now. It's this tool to find Pascal's number. So NCR, I'm not sure, do you have this slide in your packet? Perfect. You can put on there, NCR finds the Pascal number. Finds the Pascal number. That's what it does. Okay, so from here on out, you're going to actually see me write this not with 2 parentheses, but I'm going to use 3 just because our calculator requires a parentheses for NCR. So what I'm going to do from here on out, every problem, is I'm going to write what I call the bare bones. I'm going to put NCR, and you have to use a capital C in the calculator, so I'll do a capital C, followed by 3 parentheses. Let me make the first one a little bit wider because it gets 2 numbers inside of it, like this. And so what you're actually going to plug in, I'm going to do it in a different color here. It's going to be N, comma, R. This will be the A value. This will be the B value. This is technically, according to the formula chart, N minus R. For the way I do it, I usually just use the R there. And I do make this one N minus R. That won't be a big deal. I'll explain that as we go. Those are the values we're plugging in. So what does everything represent? N represents the number of plays. I'm going to use real world. Number of plays. The number of time you play the game. A represents the odds of winning. I know I skipped the R. I'll come back. Odds of winning. B represents, what do y'all think it represents? Odds of losing. You got it. Odds of losing. Now, this value, when I said these powers, they can actually be switched around. You could consider this R and this N minus R, but this right here is the number of wins. Number of wins. What this will always represent is the number of losses. This R right here, it doesn't matter if you do the number of wins or the number of losses. It can be either one. Number of wins. Number of wins or losses. Well, your teacher, Mr. Voorhees, doesn't like to lose. So I just usually go off the number of wins. I don't like losing. Okay. That might be a problem with my character, but I just don't like it. I like to win. So I'm going to do winning over there. So on this problem, it says find the 4th term. And this is where that little formula will really come in handy in a second. So we are going to find the 4th term of this expansion. So here's how you would solve this. You would write NCR followed by 3 parentheses. Y'all tell me as I fill in the numbers. I find the R last. How many times will we play this game? 10 times. What's the odds of winning? Just 1A. You were kind of silent, so I'll tell you it's 1A. The reason I'm putting a 1 is because in the calculator, we won't put the letter A, but we will put the number 1. What's the odds of losing? Wait, what'd you say? Negative 1B. Negative 1B. And that'll be just a negative 1 in the calculator. Okay, the fourth term. Here's where this formula comes in handy. Is our power, all right, I'll say wins. Wins equals plays minus term number plus 1. Maybe that's the easier way of describing that from earlier on. How many plays do we have? 10. 10 plays minus the fourth term plus 1. What is 10 minus 4? 6 plus 1? 7. We're going to have 7 wins. Whoops, I put win 7. 7 wins. So wins is going to be 7 wins. And now if you win 7 out of 10 games, how many did you lose? 3. That's why I say I usually do this as n and this n minus r, but that's what the formula chart says. So I'm going to leave it that way. And then the r can be either one. Since I like to win, I'm going to put a 7 there. So let's go to the calculator and see what our coefficient is. Over to Desmos, and this will get us our Pascal's number. NCR, got to use a capital C, 3 parentheses. The first one, we said we're playing the game 10 times, and we are winning 7 of them. The odds of winning were 1A, so I'm just going to put a 1. And we win 7 times. The odds of losing was negative 1. And we're going to do this 3 times. Now, I'm getting negative 120. Now, check this out. Over here, if you put in on the R, so the way that what you're doing on the calculator in the first NCR is for 2 values are telling the calculator what N is and R is. You could make R3 and it still gives you the same answer. Now, if you made R2, it'll change the value, but you have to have it. I just chose 2 randomly. It has to be one of those 2 powers, 7 or 3. I just always do the winning. And the answer is negative 120. So our coefficient would be negative 120. That's what the calculator says right there. All right. Now with that, I'm going to let you try DOL number 3. I want you to find the 5th term of this expansion. The 5th term of this expansion. Again, I would use those 2 things I wrote down. I would use this and the NCR portion. I would suggest you use this and the NCR followed by 3 parentheses. NCR followed by 3 parentheses. The first one has a comma. You can pause the video now. All right, so one more way you might see this is they might give it to you this way where it says find the coefficient of the x to 7th y term. And basically what this is saying is find your coefficient when you have 7 wins and 1 loss. That's another way of saying this. Find the coefficient when you have 7 wins and 1 loss. So using NCR, how many times would you be playing? Even if you didn't look at this, how many times would you be playing if you have 7 wins and 1 loss? 8. That's your N. What's your R value? Nope. It's either 7 or 1. We can go with 7. Okay, what's the odds of winning? 3x. And we'll explain what that means here starting the next problem. 3x, and we're winning how many times? 7. And then my odds of losing? Negative 4y, and we're losing 1 time. You would type that in the calculator, again, without the x and the y, and you'd have your solution here. So 8, that's a 3 without the x, and negative 4 to the first power. I'm getting negative 69,984, which I believe is the correct answer. Well, I shouldn't say correct answer because, oh yeah, it is, because all it wants is the coefficient. And coefficient does not mean the variables with it. So this would be the correct answer right there. That's my correct answer. Negative 69,984. So with that, I'll allow you to try your next DOL. DOL number 4. I'll pause the video here for you. Example 5. Let's turn this to a real world. Now, remember what I told you at the start. Number of times you play is in. R is wins or losses. A represents odds of winning. B represents odds of losing. So it says during a player's turn in a certain board game, players must spin a spinner. The 4 possible colors in the spinner can land on are green, blue, red, or yellow. If the probability of all 4 colors is equal, what is the probability of landing on green 5 out of 10 spins? So we're now getting into gambling, real world. It makes it a lot easier because the numbers start to make more sense. When I use NCR, I'm going to write out the bare bones here of just 3 parentheses. The first one has a comma. On this particular situation, how many times are we playing? 10 times. We play this 10 times. So 10 is in. That is our in. How many times do we need to win? 5 wins. So I'm going to put 5 here. Again, this could be number of wins or losses. Wins or losses. It can be either one, and it'll calculate the same. Now, what are the odds of winning? I got one answer. Hear it correctly. I want to hear it from more students. What are the odds of hitting green on the spinner? How many colors are there?
4.
Green, blue, red, yellow. 4 colors. Green makes up one of them. So it's 1 over 4. How many times are we actually going to win? 5 times. That's wins. Number wins. Okay, what are the odds of losing? 3 over 4. You can type this in the calculator now. That's odds of losing. And how many times are we going to lose? 5 times. Let's type that in. N, capital C, R, parentheses, 10, comma 5. That's the Pascal number. Pascal number is 252. And then we multiply times the odds of winning. Odds of winning 5 times. Times the odds of losing 3 times. Not odds of losing 3 times. Odds of winning, losing 5 times, but odds being 3 out of 4 that you lose. Okay, that gives you a crazy decimal. Let's change it and see if the fraction's any better. Oh, that fraction's not any better. I'll leave 1 as a fraction, 1 as a decimal. I'll just go ahead and round as well when I write it down. Approximately 6% chance of hitting green 5 out of 10 times. So I'm going to say approximately a 6% chance of hitting green 5 out of 10 times. Approximately 6% chance of hitting green, of landing green. Five out of 10 chances. 5 out of 10 times. All right, your DOL. I'll let you try example number 5 here. DOL number 5. All right, let's now see example 6 here. So I've already mentioned the binomial theorem. This is found on your formula chart, by the way, in case you forget what to type in the calculator on the formula chart. And it zoom me out. Let me come back up here. The binomial theorem, this is kind of the idea of where you get your NCR, what to type in, and where I got the powers n minus r and r there. But remember, that's what winning, losing, that can be winning or losing, which is this value right there. This is the calculator That's this part you put in the calculator. Okay, so now it says use the binomial theorem to expand all this. Again, I'm not going to do the whole thing, but if you were going to, what you would need to have is you would first start with NCR, and the values that would not change across the whole problem is we're playing this game 3 times. Our odds of winning, let's call it 2t, and losing is 3u. That would go there. That would not change. But to find the first term, so the first term, what you would do is, I guess I can do all these, is you would start with a 0. And so it's kind of like, maybe I should say it this way. It's like if you won every single time and did not lose at all. And so that's using the R as a losing one. You could also do a 3 here. You'll get the same answer. It doesn't matter what you put. So if you type all that in the calculator, maybe I will go ahead and solve this one all the way through. We would get NCR 3. That needs to be a 2 to the power of 3. And this one is a 3 to the power of 0. And so the first term would be 8t cubed. 8t cubed. The second term, all that would change is this would now, we're now winning twice, losing once. Oops, winning twice, losing once. And so if I change that, I need to change my R value in the front to like a 2 or a 1 for that matter. Doesn't matter which of those 2 numbers you choose. So I'll just copy this. Now we're saying that's a 2. That right there becomes a 2. And this is a 1. So 36 be 36 t squared u to the first power. The third term, this time around, what I would change is, for the third term, is I would put, that would be winning only 1 time, which means I'm losing twice. So I could use either of those numbers. I'll do the winning. I win 1 time. So let's copy that down. And so we have 1 there, a 1 here, and a 2 here. And I get 54. So it'd be 54 tu squared. And then finally, the fourth term, fourth and final term. This time, what I would be typing in is I would not be winning at all. So 0 wins. I would have all 3 losses. And so you could put a 0 here, or again, you could put a 3. It'll give you the same value either way. I just like doing the losing there. Okay, so we put a 0 and a 3. And my number is 27. 27. There would not be a t at all. It'd just be u cubed. So if you want to write that out, 2t plus 3u to the third power would be equal to 8t cubed plus 36t squared u plus 54 tu squared, and then finally plus 27 u cubed. And so obviously you can use binomial theorem to fully expand that. Let me go ahead and place this in on our notes here, helpful to see and be able to look at later if you needed to. So I'll go ahead and add that in right there for later on. All right, so part B, it asks us to expand this term. Now I want to just kind of walk you through again the idea, and I won't do all of these, but I will get you started. NCR. This time the power is a 4, and so that's here we would have a, and technically I want to put a 1a, so I know that, and then it'll be minus 2b squared. Okay, and so on this one, let me just go ahead and put r. I'm going to put r and n minus r that way. I think that'll help for the notes, just to kind of, I have the idea of what I was doing this time. I'll do it on the previous as well. So I do it off the winning value, and so I'm going to call r the number wins. So the number losses would be total plays minus wins, like that. And so that's our formula. And so if we wanted to write all these out in terms, the first term, what we would have, again, I'm not going to do all of them this time. The first term, we would have 4. This would be winning all 4 times. My value is just 1a, so whoops, 1 there, and a -2, and we're not losing at all, so we have 1, and so I need to change these values, and I'll just go ahead and copy it, and we can, as we go, and so this now becomes 3, 3, 1. This is now a 2, so we'll get all of them right here. I said it wasn't, but I will. I'll write them all out. Whoops. That needs to be a power of 2. This was a power of 1. I didn't realize I messed that up. Okay, and I copy this one down. 1. Now 1 win, 3 losses. And finally, if I did not win at all, I lost all 4, my coefficient. So I'll write these down, and now these would be our values. Whoops, what in the world? Okay. All right, and so now I can write out our values. So what's going to happen here is I would have a minus 2b squared. And I need to talk about this 2b squared. That's going to change the problem a little bit. Will be to 4th power of. So here my coefficient is 1. So just be 1a to the 4th power. And then minus 8a to the 3rd power. But b is normally we would say to the 1st power, but it's actually going to be to the squared power, because that's what that is. So it'll be 2 times 1 is really reality what it is. So this is already b squared right there. So it's squared times 1, which is going to be a squared power. Okay, so I'm going to write that in there. B squared. And now here it'll be b squared. So 2 times 2, which will give us a power of 4 on the next one. So it'll be plus 24 a squared. So a's continue to count down, but this time it'll be b to the 4th, because it's a b squared times this squared. This one would be b to the 6th, because it's a b squared cubed, which means there'd be, when you multiply, we'll have 6 of those. So minus 32 a b to the 6th power, and finally at the very end plus 16 b squared times 4. That's going to be 8th power, so b to the 8th power, and that would be my expansion this time around. Now with that, you can do DOL number 6. And I would suggest, I'm looking at the values here, I'm looking for ones that are unique all the way across. I don't see any that are unique all the way across. I would look for maybe the second term. The second term will at least, it might give you the right answer, but I see that there's 2 -54s. Oh, but the 2 -54s are different. Yeah, I would look for the second term. If you find your second term, you should be able to come up with your solution from there, going off of the powers then after. That's what I would do if I were you, is I would find your second term, you can underline the negative, and get your answer from there. Pause the video and then pick it back up whenever you're ready. All right, now one more thing you could see it is how could you represent this using sigma notation? So if you were going to use sigma notation, remember what we kind of do is sigma represents adding up of a bunch of n values. So on this one, what I'm going to do is I'm going to make this simpler, and I'm going to say sigma, and I'm going to use the value r here. And r is going to count. It's going to be our counter of the losers. So the best case scenario is you don't lose at all. And we're going to play this 17 times. Now there's a chance that you can not lose at all. So that's going to put r as that. And so what I would have here is within this sigma, let me do this in black. I would have, and I might do it as a different bracket so you can see my NCR followed by my 3 parentheses. And then I would close this up. Okay, my value of n on this problem we know is 17. My n is 17. My a value here would be 3x. My odds of losing is -5y. That would go there. Now, the r is what's going to be plugged in right there. So this r needs to stay as an r and sigma. I would not replace that because that's where sigma would feed in those numbers. So this is, on this case, going to represent losing, and we start with not losing at all. We want to lose 0 times. So for this sake, I'm going to do n minus r here. That means the wins will be n. I'm sorry, I put n there. We know that's 17 possible wins minus r. So best case scenario is plugging in a 0. You win every time. Second best would be you plug in a 1 instead, so you lose 1 time. So that means 16 wins, 1 loss. Next best scenario after that would be a 2 goes in. 2 goes in there. So 17 minus 2 is 15. That's 2 losses. So 15 wins, 2 losses, and so on. And so the calculator would just count up from there. That's the idea. And so that's how it would look in sigma notation right there. That's the correct answer. But you'll see this written different on the DOL because NCR, there's another way of writing NCR, and that is by using a kind of a vertical parenthesis like this. And the n value goes up top. The r value goes down below. And so this is actually the way you would see this one if it were your DOL, is it would look like this. 3x to the 17 minus r, and then -5y to the r. And so I want to, here's the way I would write it in sigma notation. So I'll circle that one up. Here's the way the DOL on the next slide, multiple choice, the multiple choice on guided practice number 7 is written. And so that's the kind of the idea how it would be written like that. Okay, with that, let me actually show you your problem. So you can look at your values to get the correct solution here. Is represent this expansion using sigma notation. So again, I'm going to kind of walk you through it just because I think it's more helpful if I do. These parentheses are representing the NCR. That's the NCR. That is saying NCR of 18 comma and whatever the r needs to be for this particular problem, which should be a counter. And we should count the best case scenario if r is talking about losing, is to lose 0 times, which eliminates this one, losing 0 times and winning up to 18 times. 2y is the winners. This doesn't even have the NCR, so that one's out. So you're now looking at between these two. 2y is the winners. Losers go there. This one's saying you always win 18 times. That's not possible. So it looks like the answer would be C here. And now finally, let's take a look at how this might look on the ACP. So the first thing is, what is the fourth term? Now, you might not remember that you could say 8 minus 4 plus 1 will be the number of wins. So wins would equal 8 plays minus the fourth term plus 1, which 8 minus 4 is 4 plus 1 equals 5. You might not remember that. So the way to do this is saying, okay, the best case scenario is to win 8 times. Next best is to win 7 and lose 1. Next best, which I could put on there, lose 1. Next best would be to win 6, lose 2. Next best, which is the fourth, is to win 5, lose 3. You could write them out like that and just count which is the fourth term and get there. Or you could just use that formula. So here's what I know. I'm going to use NCR. We're playing this game 8 times. We're going to win it 5. The odds of winning is 3x. We're winning 5 times. That's our winner right there. That's our fourth term. And we're going to lose it -2y times. That's the odds of losing. We do that 3 times. You plug that in the calculator without the x and y, you come up with your coefficient and your solution. You can pause this video, type that in to get that solution. The next ACP problem. Okay, this time it's just telling you the actual term. That's great. So this is telling us we have 5 wins, 5 losses in essence. So it says, what's the coefficient of the x to the 5th, y to the 5th term, the expansion? So here we would just go NCR. Our N is 10. R can be either wins or losses. I'll do wins. I guess it's the same, doesn't matter. The odds of winning is 1x raised to the power of 5. The odds of losing is negative 2y raised to the power of 5. You can type that in the calculator again without the x and get your solution there. And you can pause the video to get your solution or coefficient. Finally, last one. What is the coefficient of the 5th term in this expansion? So it's 5th term, so wins will equal plays, just 12, minus the 5th term, plus 1. 12 minus 5 is 7, plus 1 equals 8. In case that didn't work, you'd say, well, best case scenario is winning 12 times. Next best is winning 11, losing once. After that, I'd prefer to win 10 times, lose twice. If that didn't happen, I'd prefer to win 9 times, lose 3 times. And if that did not work out, I would hope I would win 8 times and lose only 4 times. That is the 5th best scenario. So that's the 5th term. 5th term. You can do it that way. And so NCR, and we're playing a total of 12 games. We're hoping to win 8 of them. The odds of winning on this situation is 3x. We want to win 8 times. The odds of losing is negative y. We're hoping that only happens 4 times. Type that in the calculator. Oh, I should say negative 1y. So you type that in the calculator without the x and y, you can come up with your coefficient there. Once you get your answer, go ahead and scan your QR code and upload your answers.